Alright, today our lesson is on transforming polynomial functions. We did this back in Algebra B. Just remember, transformations have stretches. We're going to do translations to the left or right or up or down. And our objectives for the day, we're going to be able to apply transformations to graphs of different types of polynomial functions. So as a quick review, let's go over how our quadratics behaved. Remember, our general form was y equals a parentheses x minus h quantity squared plus k. And if you remember, the a is the variable that does the shrink or the stretch, or it flips it. Remember, it flips when a is negative. The h variable shifts our left and right, so that's our translations. And remember, in our basic formula, it is minus h, so it's always opposite. And then our k is our vertical translation. So remember, positive k makes it rise up, negative makes it go down. Alright, now, with our polynomials, our quadratics, remember, that was our family, and that made up every type of quadratic. With cubics and any higher degree, there's not one family that works for everything. So we have a few that work under this, but not everything. Let's try a basic transforming a cubic now. So this is going to be problem 1. And we're going to transform our basic cubic. So we're going to have the equation y equals x cubed. I want to translate this left 3. I want to stretch by a factor of 2, and I want to go down 4. Our general cubic looks very similar to this when we're talking about translating this, just this basic parent function. It's going to take on the form y equals a x minus h cubed plus k. So very, very similar. And we're going to place the numbers in just like we have before. So it's going to be y equals, we're doing the a, remember, is our stretch factor. So we are stretching by 2. So we're going to say 2. And then x minus, since we're going left 3, that would be a negative 3 to the left. So we're going to make this a plus 3 squared. And then we're going down 4, so we're going to have minus 4. Alright, we've translated that. Left 3, down 4, and stretched it by a factor of 2. You can confirm by graphing. The second type of problem in this lesson we're going to be finding zeros again of cubics. So we've found zeros the past few days, and we're going to do it once more. So if we have the cubic y equals 3 x minus 1 cubed plus 6, instead of expanding out that trinomial, we can actually just solve for it a lot easier. We're going to replace the y with a 0 when we're trying to find a root. We're going to solve, so we'll move the 6 over. Then divide by your 3. So we have x minus 1 cubed is negative 2. To get rid of the cube, we do the opposite and do the cube root. When you do cube root, we do not have to do the plus minus. And you can actually have a real number that is a cube root, because negative, negative, negative makes the negative 2. So the negative is alright. We don't have to deal with imaginary units here. So we can pull out the negative sign. We have the cube root of 2. 2 won't simplify. We're just going to leave it alone. Last step, we'll move the 1 over. So our root is going to be 1 positive when we move it over minus the cube root of 2. So there's our root. Alright, so we want to write a quartic function with only 2 real zeros at x equals 0 and x equals -6. So if those are our roots, we know when we go back to the function, we don't have our conjugate theorem that works here. We're just going to work back when we know that one factor is x, the other factor is going to be x plus 6. And we know if it's a quartic function, it has to have 2 more factors, but we don't know for sure what they are. We're just going to make up something, but I want to make it imaginary, so let's do like an x squared plus 1. And that's guaranteed to be imaginary because if it was -1, it would be a difference of squares. We could solve it, but we know that this x squared plus 1 gives us an imaginary solution. Alright, and then now we just need to distribute and FOIL this back out. So we're going to have x cubed plus 1x plus 6x squared plus 6. Don't forget about my x factor out in front. Distribute it, that will be x to the 4th plus x squared plus 6x cubed plus 6x equals 0, and I'm going to clean that up and just write it in descending order. So x to the 4th plus 6x cubed plus x squared plus 6x. And we're going to set that equal to y. So there we have a quartic function that has 2 real zeros at 0 and -6. The other 2 zeros, if we remember, would be at I.